What I have right here is an Atari Jaguar. I've never seen one in the wild. This is the first time I've ever touched one, for sure. And it was sent to me by someone to fix. That is pretty daring, considering I've never even seen one. In any case, it came with the cheapest, Chinesiest power supply of all time, so I didn't even plug that in because I don't trust it, simply. And I decided I'll use my bench power supply. And it draws almost no current, and the LED doesn't light up. So, that's broken. Let's find out why. Okay, so that's my bad. Apparently the thing doesn't even turn on at all if you don't insert a game cartridge, which makes no fucking sense whatsoever. But, okay, so I put in the game and I turn the machine on. It does draw current, but this doesn't look very good. I'm pretty sure no matter how bad the games are, that's not supposed to look like that. So, let's see what's going on here. So, what we have right here is what's supposed to be the composite video signal. Does this look like video to you? Sure doesn't to me.
Actually, this kind of explains what we saw on screen, because I used a really cheap USB composite video capture dongle, and it just tries to display something if it receives anything on its video inputs. It just turns up the gain really high and tries to output whatever to the frame buffer.
But let me just show you what happens when I power cycle it. It stays low, and then it slowly comes in at some point. Okay, so video and cap issues aside, I found something very strange. On the data bus, on the CPU data bus, we've got some normal data lines. So this is D4, this is D5, normal activity, and here we've got D6. That is not normal. That is fairly screwed up. And the thing is, according to the schematic here, D6 comes from U26, which is just a normal 245 buffer. We can see that pin indeed has something on it, but by the time it gets to the Motorola, or it gets to anywhere else, it doesn't. There seems to be a break in the PCB somewhere. Let me see. I actually believe I found the culprit. The leftmost via right there, that one, doesn't have continuity to the other side of the, or rather to the chip. I'm gonna desolder this chip and see what goes on below it. Well, won't you take a look at that? That is not how that's supposed to look. I wonder what happened here. I think it's pretty far away from any cap juice. Here's your problem. With a non-functioning data bus, obviously you're not gonna get very far. Anyway, let me just clean that up and put a small piece of wire or something through that. Okay, so I put some really thin wires through the vias there. Now that should have perfect continuity. Now I'll put the chip back. Easy as pie. Well, I got the chip soldered back in place. Let's see what it does now. Same shit as usual. Meh. Underwhelming. Found a little bit of a thing here. Appears there's been some corrosion damage or something.
This is on the Atari custom chip named Tom. It's labeled Jaguar CPU on the chip itself. As you can see here, there is a loose pin. And everything is really oxidized and corroded.
That's fucked.
Here I'd removed the previous owner's attempt to fix this, and I'm trying to scratch away all the corrosion and oxidation of the pins and the pads in order to rework this properly. Here I'm scratching up the solder mask of the broken trace in order to put a wire above it to basically replace the trace and reconnect the pin. So that's the rework of the TOM chip completed. However, the machine still didn't do anything.
Okay, so I noticed something. It is that A0 of the ROM never seems to do anything. Like, obviously the bus is gonna be whatever, 64 bits on this weirdo CPU. And it's got some lines, mask A0, mask A1, mask A2, which are then A0, A1, A2 of this 8-bit ROM chip. So to read like a 64-bit words, it would have to read 8 separate bytes of this ROM. So we should see some toggling on A0 for sure, but we don't. So A1 looks completely normal, and A0 is really messed up. A0 on the mask ROM, mask A0, U30 pin 2. Well, that looks more normal. Okay, so I found a whole bunch of connections here, and one of them is the one for the address line for A0. And you can see there's corrosion here, and the connection between this pin and this via is broken. Now these other connections seem fishy, but they seem fine at least. This one's okay. This one's okay. This one's okay. This one's okay. This one's broken. This one's broken. Oh my! So lots of connections to fix here. After fixing those connections, we get a red screen of death. Look, it's like it actually does something. Jaguar. Well, that's pretty cool. Now to figure out why the fucking game isn't loading. Let's take a look. D31 looked a bit weird on the oscilloscope on the cartridge bus, and I can't imagine why. Look at that one. Notice there was no continuity to the buffer where it comes from, which is U17, pin 11, the last pin there. D31 does some toggling on this pin. There's nothing to be found on the cartridge connector. I'm leaning towards desoldering this cartridge slot, but I think maybe if that's the only thing wrong, that's the only data or address line I could find that had weird issues, I might be able to get away with this without taking off the cartridge port. But while inspecting that, I also noticed that there's a bunch of corroded connections over here. It's almost as if there's been some kind of like liquid damage in this machine or whatever. Okay, I got the cartridge slot removed, and boy does it spell trouble. Good thing I did that, because there are a few traces with weird stuff going on here. I wouldn't have seen those two, for example, and the two above it, which would have been covered, and those. So that's gonna need some work. Also that, blech. I don't know what happened in here. Alright, here's some fixes. Some wires. Really thin wires bridging the traces. Here especially a few. These traces are all fine actually. They've been tinned. Here as well. Everything's okay. It looks kinda nasty, but it's fine, trust me. So I'm gonna solder the cartridge slot back in and we'll see where we stand. Okay, well, that was certainly something. You'll notice that the ROM has been replaced, or rather socketed and replaced with a flash chip. And a whole bunch of other things have happened here. Basically, when I redid the traces underneath the cartridge slot that were broken and stuff, and resoldered the cartridge slot, everything exploded. That's not even an exaggeration. There was a piece of debris that got caught between the plus 9 volt supply and a data line, D4. And the problem was that alongside that, it blew this buffer, it blew the ROM chip, it blew one of the ROM chips in the Cybermorph cartridge, it blew this buffer, it blew this buffer, and it blew this buffer. That was not fun. However, I did replace that. I socketed the ROM chip, I replaced the bad ROM chip in the cartridge with an EEPROM. So once I replaced all these chips, I managed to make it boot once in about 50 tries. And I was perplexed because this is a data buffer, right? If it blows up, nothing else really should be affected. However, there was a trace here that was corroded, the enable signal for this buffer. This buffer's the address, the lower half of the address lines for this ROM chip.
Actually, the whole expansion bus, so also for the cartridge slot.
It was corroded away and I had to fix the trace. Then finally managed to make it boot consistently, at least.
There was, however, some issues with it. For example, the machine would only boot up in NTSC mode, which is quite strange because it's obviously not an NTSC machine. If we take a look at the schematic, we can exactly see why that is the case. These hardware configuration straps are connected to B4, B5, B6, B7, which go to this buffer chip here, this U2574HC244. So that chip was actually also blown alongside, well, every other chip that was connected to the expansion data bus. Yeah, this ED4. Interestingly, all of them failed silently except for this U26, which decided to combust into my face, which was decidedly not fun.
And then I realized, oh my god, the game is broken as well, because obviously the ROM is also connected to that same data bus, the expansion data bus.
The Atari Jaguar cartridge slot has a 32-bit data bus, but ROM chips usually don't have that kind of data width. And since it's highly doubtful that Atari actually made custom ROM chips for this, they just relabeled an off-the-shelf part. Cybermorph is a 16 megabit or 2 megabyte game, and inside the cartridge there are 2 EEPROMs, each making up half of the 32-bit data bus. So for any given accessed address, one EEPROM will return you the upper and one will return you the lower 16-bit word. The affected blown data bit was therefore only able to kill one of the 2 ROM chips. I've actually desoldered and dumped the faulty ROM chip, which as expected I was able to read as a regular 27C800. And as you can see in this hex editor, on the right side here you can see a verified good dump from this game's ROM chip. For the highlighted data word it's supposed to give back 0000, but the faulty ROM chip gave 0040, truly confirming that this chip is completely and utterly toasted.
So let me just tell you, sourcing an EEPROM is actually not as easy as I thought it would be. I had to buy one on eBay and it cost me $5. And this EEPROM is a 27C160, which is 16 megabits, which is twice the size of what it should be.
So how can you use a ROM that is obviously too big for this purpose? Well, the thing is that these were all designed with these sizes in mind, and the pinouts are compatible between the 27C800 and the 27C160, and the 27C322 for the most part, which is the 32 megabit variant. The thing is, the 16 megabit compared to the 8 megabits variant has one extra address line, A19, in order to be able to address that extra data. But what you can do is to tie this address bit to a fixed value, making it only able to address one half of its content and essentially turning it back into an 8 megabit EEPROM. Now I had the absolutely brilliant foresight that I should only write one half of the ROM and leave the other one untouched and blank, just in case I screwed up and need to try again. And boy did I screw up. I accidentally wrote the broken dump of the broken ROM chip to the new one. So what I just did was I wrote the correct data into the second half and then flipped A19 around by tying it to VCC instead of ground, turning it from a 0 into a 1.
So anyway, let's see this thing in action. It's still hooked up to my bench power supply, except now I'm running it with a 1 amp current limit because, yeah, in this phase of uncertainty when things blew up, I really didn't want it to draw 5 amps or something. So let's turn it on. So yeah, really there's not much else to say. It's an Atari Jaguar, it works. Cybermorph still sucks. I played about 2 minutes of it and I got bored. I wish the guy had included Tempest 2000, so at least we could have had some fun after repairing this, but whatever. I cleaned up the soldering. I also replaced some of these caps that have been replaced with really questionable types, you know, 85 degrees, Chinese brand caps. So these are at least nice and shiny now. So yeah, time to put this back in its case and get it shipped out back to its owner, and hopefully he'll enjoy it for a long time. In hindsight, this was not as bad as I thought it would be, simply because the full schematics in perfect quality are available for this thing. So it was actually really easy to trace all the relevant buses and signals. So that was really nice. Regardless of this thing being a failure in every measure imaginable, be it commercial success or quality of the games produced for it, I really did enjoy working on it. And having done this, I now feel confident that I probably could fix another one of those. And I have to thank the owner of this machine, who I don't know by the way, as I said in the beginning, that he trusted me with this. So it means that my reputation among my friends is worth something, I guess. So, good stuff! I'll see you next time. Bye!